Hello, everyone. In the last section, we worked on factoring quadratics. In this section, we look at an application of that, how it can be used to solve equations that are in factored form. To start, though, I'd like to challenge you with a few kind of special case factoring problems. So if you would, you can either try at the bottom of the most recent homework, or maybe in the margins of the note packet for the day. I'd like you to try the following question. Can you find for me two numbers, or actually I'll just let you try the problems. Can you factor the following polynomials? I'll give you a little hint though. If there's nothing in the middle, maybe try writing a 0. So if you would, pause the video now for maybe a minute, see if you can factor the following, and unpause it once everyone's had a chance to try. So pause the video now, please. Okay, let's see how you did. We learned that when you factor quadratics in standard form is what this is called, you need to find two numbers that multiply to make the last term and add up to make the middle term. Well, for the first one, two numbers that multiply to make negative 16 and add up to be 0, those are going to be 4 and negative 4. So it'd be x plus 4 and x minus 4 will do the job. If you try the second one, I need two numbers that multiply to make a positive 16 add up to be a 0. Now notice this, if it multiplies to be a positive 16, I know that they either both need to be positive numbers or they both need to be negative numbers. If they were both positive, is there any way to add up to be 0? I don't think so. If they're both negative, is there any way to add up to be 0? I don't think so. So it turns out this one is not factorable. So just like in middle school when you were studying factoring, you were studying factoring of numbers, not all numbers are factorable. Like in middle school, they might have asked you to factor 15. And you would say, oh, I can do that. It's 3 times 5. But then they might have asked you to try to factor 17. And you'd say 17 is prime. It cannot be factored, besides obviously 1 in itself. So just like some numbers are not factorable, we call them prime, some quadratics are also not factorable. So there you go. If you would, please, how about the note packet for today? The title of the section should be on solving polynomial equations in factored form. Some lead-in ideas that you need to understand we're going to go through right now. So let's say I have three numbers, x times y times z, that all add up to be 0. But let's say that I tell you that x is 2, y is 3, and you don't know what z is. Now let's think about this. If you have 2 times 3 times z equals 0, what do you know that z has to be? Well, z obviously has to be 0. If you have a long chain of multiplication, and the product equals 0, at least one of the items has to be 0. And if x and y are not the 0 part, then z has to be the 0 part. So z would have to be 0. We talked about this in middle school because this is just numbers. Now 2 and 3 are kind of the high school version of this concept. Let's say it asks you to solve for x if you have the following. X plus 2 times y equals 0. Again, I've got the one thing, x plus 2, times the second thing equaling 0. But I'm telling you now that y is 3. If y is 3, that means this blue part cannot be the 0 part. It must be the red part that's going to be the 0. And the only way this red part would be 0 would be if x equaled a negative 2. So x has to be a negative 2 in order for this red part to be 0. If x was negative 2, we'd have negative 2 plus 2. That'd make 0. And 0 times 3 would equal 0. So there's our answer. X has to equal negative 2. Now the last part. What if I told you that quantity x plus 5 times the quantity x minus 3 equals 0? I've underlined them again. Red thing times blue thing equals 0. That means one of these things has to be 0. 0 is the only number this works for. For example, if I told you red thing times blue thing equaled 8, does that mean for certain one of the numbers has to be 8? No, it could be, because it could be 1 and 8, but it could be 2 and 4. However, if you know the product is equal to 0, one of those things has to be 0. What would make the red thing be 0? Well, if x equaled negative 5. If x equaled negative 5, then what would happen? Well, we would have negative 5 plus 5 times negative 5 minus 3. That would be 0 times negative 8, but that would still equal 0. So x could equal a negative 5. What if it was the second thing that was 0? Well, in that case, it'd have to be x equals 3. If x equaled 3 and I put it back in, I'd end up with 3 plus 5 is 8. and then times 0, which is also equal to 0. So my two answers are x equals -5, or x could have equaled a 3. Those are the two values that will make the whole entire statement be 0. This is a very special property for 0, and it has its own name. It's called the zero product property. It's the multiplication property when my product of the two items is going to be equal to 0. It's read as the following. Let's say a and b are real numbers, so there's some numbers. We know a times b equals 0. So I know red thing maybe times blue thing equals 0. That means either a is equal to 0 or b is equal to 0. One of them is equal to 0, though. That's a very important property. It's what actually allows me to solve a lot of equations when I have quadratics, powers of 2, is this zero product property. 0 is the only number this works for. We're going to use it to solve some equations where we are already in factored form. So for example, let's say I have x plus 3 times x minus 5 equaling 0. That means one of those things has to be 0. What would x have to be to make the first thing be 0? Well, it'd have to be a -3. What about the second thing? Well, if x equal to 5. If x was equal to either one of these items, if you put them back in, it would make one of those equal to 0, and therefore the whole chain would multiply to make 0. What about the second one? If I have x plus 14 times x minus 3 equaling 0, either the first thing being 0 would occur if x equaled -14, or the second thing would be if x equaled 3. One of those has to occur, so x either is a -14 or x is equal to a 3. What about this, though? What if it's kind of written out where I just can't say, oh, it's just the opposite sign? I actually need to solve for this. So I know either 2x minus 1 is equal to 0, or I know 3x plus 1 is equal to 0. Then I need to solve. This one I'm going to end up with some fraction answers. Add 1, I get 2x equals a 1. Divide by 2, and I get a half. Either x is equal to 1/2, or subtract 1, I get 3x equals -1. Divide by 3, or x equals a -1/3. Those are my two answers. If I substitute either of those x values back into the equation, I'll get one of the factors being 0, and therefore the whole thing is 0. I'll zoom this out just to give people a chance to look at it in case you missed anything. You need to say one of the items needs to be 0 because they are multiplying. That's the operation going on in between here and making 0. If you have two items multiplying to make 0, one of them has to be 0. I'm going to give you a chance to try now. So pull out your whiteboards. Your two to try are the following. So solve each of these. Each of them. So pause the video now for maybe a minute and a half. Unpause it once everyone's had a chance to try on their whiteboard. If you get an answer, check with a neighbor. So pause the video now, please. Okay, this is what you should have got. Either the first or the second item is equal to 0. The first one would occur if x equaled a positive 2.5. The second one would occur if x equaled a -3/2 or -1.5. The second ones you're going to have to solve a little bit for. Either 4x plus 8 is equal to 0, or 3x minus 5 is equal to 0. But one of those has to be 0 if they multiply to make 0. This would give me, subtract 8 divided by 4 would be -2. This one, if I add 5 and then divide by 3, I get 5/3 or 1.6 repeating. So there you go. It's a very, very helpful tool. Now we're going to play a little game. So hopefully you've got your calculator out. What I'd like you to do is try via guessing and checking to find values of x that is going to make this left side equal 0. So can you find a value for x I can put in that will make the left side equal the right side equal to 0? So I'm asking what values could I put in for x that would make the left side equal 0 and therefore the right side also equal to 0. I'm going to show you a little tool that you can use in the calculator called storing a variable. So I need to shrink my screen. Give me just a second. Is it going to let me? Maybe it won't. There we go. Okay. Just want to be able to fit. So this is what you can do. You can store a variable. So for example, if I type in like 5 and then I hit this STO button down here and then store and then for x and then hit enter. Now if I grab x again, type like x plus 8, it knows that x is 5. So 5 plus 8 would be 13. I'm going to use that to do quick checks here for my equation of x squared minus 15x plus 54. So, well, maybe let's just check 1. Put 1, store it for x, and then hit enter, and then type your equation. X squared minus 15x plus 54. If I type that in, does it equal 0? Nope, it equals 40. So 1 doesn't work. If I put 1 in for x, it does not make the left side equal to 0. So I want you now. You can use the calculator to guess and check, or you can just plug numbers in by hand, however you'd like to. Try to find a value for x that will make the left side be 0. So pause the video now for maybe, I'll give you a minute. See if you can find a value for x that'll work. Unpause it once everyone's had the chance to try. So maybe you were successful, maybe you weren't. Turns out there's actually 2 values for this, and the strategy of guessing and checking turns out to be a very poor strategy. Most of the time in mathematics it is. So what would be a better strategy? What if we'd factored the left-hand side? What if I asked you what 2 numbers multiply to make 54 and add up to be a negative 15? Well, you would say it's going to be x minus 6 and x minus 9. Then they equal 0. Then you'd have a much better chance at finding the values because you know one thing times a second thing equals 0. So one of them has to be 0. So your answers are actually going to be x equals 6 and x equals 9. Maybe some of you found one of them, maybe some of you found both of them, but guessing and checking was an awful strategy. Here's how you could have used the calculator. If you type in 6, store it for x, and then type your equation in again, or actually if you just scroll up and hit enter once the equation's highlighted, it will copy and paste it again, and I just run it, and you'll see it equals 0. So x equaling 6 is one of the solutions. The other one is if you use 9. So the best strategy to solve quadratics, if you can, is going to be to factor it first. So we're going to solve by factoring first. That's why we practiced it, because it's the #1 tool that we can use to solve quadratics. So here we go. I need a factor. I need 2 numbers that multiply to make negative 42, and this is actually a negative 1. So I need to add up to be a negative 1. So if they're multiplying, they need to be opposite in sign, and they add up to be a negative 1, it means the bigger factor has to be negative. So you search around until you found them, but it's x minus 6, or sorry, x minus 7 and x plus 6 are going to be your 2 factors. Now I solve. I know one of them has to be 0. If it was the first one, x would have to equal 7. If you put 7 back into the original equation, you'll see it equals 0. If it was the second one, it would be x equals negative 6. If you put negative 6 in for x, it would work. Let's check the 7. We can almost just do this mentally. So the original equation was x squared minus x minus 42 should equal 0. If you put 7 in there, 7 squared is 49. 49 minus 7 minus 42, that equals 0. So it checks out. You could do it for negative 6 as well. It's going to work. Let's try another one. X squared minus 10x equals 24. I told you at the very beginning that that property of 2 numbers multiplying where one of them has to equal the right answer, the right being the direction right, will only work if one of the values that you're doing has to be 0. So the product needs to be 0. So I need this right side to be equal to 0. So I need to subtract 24 to get it set up at first. So subtract 24, then I'll have x squared minus 10x minus 24 equals 0. I can't combine 10x and 24. Those aren't like terms. So your first step is to get one side equals 0. Second step is to solve by factoring. Now I need to get 2 numbers that multiply to make negative 24, add up to be negative 10. If they're multiplying to be a negative, one has to be positive, one has to be negative. Some people will say minus 6 and minus 4. Those definitely add up to be negative 10, but they do not multiply to be a negative 24. Negative 6 and negative 4 make positive 24. So they have to be opposite in sign. It's going to be x minus 12, x plus 2. And then you solve. This would be 0 if x equaled a positive 12. This would be 0 if x equaled a negative 2. And that's how I can solve by factoring. Get one side equal to 0, and then factor, and then use the fact that if I have 2 items multiplying each other, either the first or the second item has to equal 0. So then you can solve for your 2 answers. You'll notice there's 2 answers because you have a power of 2. That's an important property that you'll study in later math lessons. I'm going to give you a chance to try before we try one last application one. Can you solve by factoring? First step, remember, is get one side equal to 0. So pause the video now. Give everyone a chance to try. Maybe unpause it after a minute and a half, and everyone's been able to attempt it for themselves. Okay, here we go. This is how this one works. Get one side equal to 0. If you subtract the 16 over, and you need to write it from highest power to lowest power, so x squared minus 16x plus 48 is how it should be written in standard form. Highest power 2 down to 1, then power of 0. X to the 0 is 1, so that's why we call them 48 ones. Now I factor it. I need two numbers that multiply to make positive 48 add up to be negative 16. Those two numbers are going to be minus 4 and minus 12. And your two answers, therefore, are x equals 4 and x equals 12. You could check, let's check the 4. If I put 4 in there, 4 squared is 16, and 16 plus 48 is 64. And 16 times 4 is also 64. So 4 works. 12 will work as well. And try an application. It turns out that quadratics, we will see, when we graph them, they make a shape called a parabola. So parabolas can open upward or downward. The most useful version is the ones that open downward because they model anything that moves through the air. And when people jump, we follow a parabolic path. So here is the equation that we use for it. The height measured in feet of a projectile. A projectile is anything that moves through the air. Usually it's fired, but it can be self-launched like a person jumping. The height of a projectile can be modeled, tracked. Equation h is equal to the height is equal to negative. We'll learn it's a downward. Whatever goes up has to come down. The 16 is the constant for Earth. This number of 16 is for Earth. As I said, this number would be bigger if we had a larger planet that had more gravity. So if this were Jupiter, this would be a number much larger than 16. So negative 16, t is the time that you're asking about, squared because it has to be a parabola. Whatever goes up must come down, plus the speed at which you take off times t, again the time that you're asking about, s. S stands for initial position. We chose S because of position, the S in position. So here's an example. Clyde Drexler was a famous basketball player that played in the 80s and 90s. Here's a video of actually the dunk that we're going to be asking about. I will play it right now. So he takes off, seems almost hang in the air, and then comes back down. As he takes off and then comes back down, if you tracked the middle of his body, you would see that it makes a parabola. So we can model his jump using mathematics. Clyde Drexler took off for his dunk with an initial upward velocity or speed of 16 feet per second. How long was he in the air? So if I write height h is equal to negative 16 times t squared, plus I know his v is equal to 16 as speed, so I'm going to put 16 in for v, times t, I don't know the time, because that's what I'm solving for, plus s, well, s is 0, because he took off from the ground, so I don't need to write it in there. There's my equation. H is the height at which he eventually comes back down, because I want to know how long was he in the air, so how long when he was in the air was his final height would be 0. So final height is going to be 0, so I have 0 is equal to negative 16 t squared plus 16t. Now I'm going to factor this, and I'm going to factor this one by doing greatest common factor factoring. What two numbers can I divide out of negative 16 and 16? We did this a few lessons ago. It is a negative 16. How many variables can I divide out? Well, t squared and t both have a t, so I can divide a t out. What's left behind? Well, this first one has a t left behind, and when I take 16 and divide out a negative 16, I have a minus 1. There's no more t's left behind. So there's my two factors. Now I have one thing times a second thing equals 0. Well, this first thing would be 0. Let's put the colors back away. So I have negative 16 times t. What would t have to be in order for this thing to be 0? T would have to be 0. Negative 16 times 0 is the only way to make 0. Some people say positive 16, but you're multiplying. Negative 16 times a positive 16 does not make 0. This last one is 1. So the two times at which he has a height of 0 are 0, because this is when he took off he took off at time 0, and then the other time at which he has a height of 0 is when he lands, which means he was in the air for 1 second. And it turns out it's actually physically impossible for a human, using just their own muscles and no extra aids, to be in the air longer than a second. If you don't believe me, maybe at lunch, have a friend time you. Jump as high as you can, have them time the time from which you took off, your feet were no longer touching the ground, to the moment at which you make contact back on the ground. It will never be longer than a second. That is it for today. Thank you very much.